Algebra 1, Unit 6, Lesson 6.6, Parallel and Perpendicular Lines, Part 2, Pearson, Algebra 1, copyright 2009. I'm Mr. Pilarski, and our objectives today are I will be able to determine if two lines are perpendicular, and I will be able to write the equation of a perpendicular line. Our key words, some of our old friends from previous lessons. From Lesson 6.1, we have our old friend, the slope. We do have a slope formula, but for this lesson, it's going to be important to remember that the slope is represented by the variable m. This is something new today, negative reciprocal. Lesson 6.5, point slope is useful because if you know the point and the slope of an equation, you can write it in any other form of an equation that you want. Lesson 6.2 is the slope-intercept form, probably by far one of the most useful of the three forms that we use. We just learned about parallel lines in Lesson 6.6 Part 1, and the new word, perpendicular lines, we're going to learn about in this particular lesson. Let's get to it. Algebraic property. Slopes of perpendicular lines. Two lines are perpendicular if the product of their slopes is -1. A vertical and a horizontal line are also perpendicular. This little stipulation or last sentence about vertical and horizontal lines is necessary because the horizontal lines have undefined slopes. So we couldn't multiply to get -1 to hold true. So this is true for everything but this situation. Here's a little example. The slope of y is equal to -1/4 x minus 1 is -1/4. So for the equation, y is equal to -1/4 x minus 1, the slope is 1/4. Now, -1/4. If you don't know why it's -1/4, here's why. Because it's in slope-intercept form. That's why it has a slope of -1/4, down 1 into the right 4 if you were graphing it. Now, the second equation, it says the slope of y is equal to 4x plus 2 is 4. So y is equal to 4x plus 2 is 4. So we know the slope is 4. Since -1/4 times 4 is equal to -1, here, showing you what that means exactly, -1 times 4 is, or negative times a positive is equal to a negative. 1 times 4 is equal to 4. 4 times 1 is equal to 4, and that simplifies to -1. That would be how you would show your work to prove or to justify that these two equations have negative reciprocal slopes, and that's the important thing here. The slopes of perpendicular lines, so I'll talk about that little key phrase there, negative reciprocal slopes. The slopes of perpendicular lines, yes, the product of them are, the product of the two slopes is -1, but the little key phrase here, this important skill, some vocabulary, negative reciprocal, because the slopes of two perpendicular lines of negative reciprocals, it's important to be able to identify a negative reciprocal very quickly. So if two numbers are negative reciprocals, then their product is -1, which means then that the lines are perpendicular to each other. So real quick, let's run through finding some negative reciprocals. Negative meaning the opposite, and reciprocal meaning flipping the fraction, if you will. So in this problem, we're given the number -2. Now, it's not a fraction, but we can make it a fraction by putting over 1, and its negative reciprocal would be a positive 1/2. The negative or opposite of -2 is a positive, and the reciprocal of 2 over 1 is 1/2. So the negative reciprocal here is 1/2. We can show that they're negative reciprocals by multiplying if we want. If they're negative reciprocals, they're going to give us a product of -1. A negative times a positive is a negative. 2 times 1 is 2, and 1 times 2 is 2, and that does simplify to -1. So the negative reciprocal of 3/5 it's a positive number, so the negative of that is negative, or yeah, a negative, or the opposite of the positive is a negative. And the reciprocal of 3/5, inversing it, turning it upside down, if you will, gives us 5/3. So the negative reciprocal of 3/5 is negative 5/3. -4, this example C, is just like -2 in example A. We can put it over 1 to make it a fraction so we can visualize it easier if we need to. So the reciprocal is 1/4, and the negative of -4 is a positive, so this would be a positive 1/4. B is similar to B, but we're starting with a negative, so we know our negative reciprocal is going to be positive. So when we inverse these numbers, the negative reciprocal of -5/6 is a positive 6/5. Now, if you're my student watching this video, here's some bonus notes. When I'm done with these bonus notes, you're going to want to pause, copy this down, put your name on it, and give it to me in class, and you're going to get some bonus points. Don't make a big deal about it, just turn it in. Anyway, here's a good example. Are the two lines perpendicular? Taking the idea of negative reciprocals, that we know the slopes of these two lines need to be negative reciprocals, what we need to do is 2 steps here. And what we need to do is first find the slope of each line. So I'm going to do that. Now the slope of this line is real easy because it's in that slope-intercept form. I can easily identify the slope. The slope in this case is equal to a -3. Now in this equation, to find the slope, I got to solve for y. I have to put it into this form. It's not quite in this form. We got 3 times y here. We got to get rid of that times 3, so we have to divide each side of the equation here by 3. When we do that, 3y divided by 3 leaves y. Bring down the equal sign. 1x divided by 3 is 1/3 x. Remember, that coefficient right there is a 1. So 1/3x, or 1/3 x. And -6 divided by 3 is a -2. Now we can identify the slope. The slope in this equation is equal to 1/3. Now we can see that they are negative reciprocals of each other, but we should show that, and that's our second step. We're going to call that determine if the lines are perpendicular. Now here's the symbol for perpendicular. So like an upside down T. So I'm going to take -3, multiply it by 1/3. Remember, we can put that -3 over 1 and multiply. A negative times a positive is a negative. -3 times 1 is 3. Over 1 times 3 is 3. And that does simplify to a -1. You may ask yourself, why is that important to write? Well, it is because you want to be able to show that they are negative reciprocals. And we just showed that the product of them does give -1, even though it's very simple math. Example 3t, writing equations for perpendicular lines. Write an equation of the line that contains 6, 2 and is perpendicular to y is equal to -2x plus 7. As previous problems, this is going to involve multiple steps, and the first step is to find the slope. Now, the first step for a lot of what we've been doing in the last 2 or 3 lessons has been to find the slope. And more specifically, we want to find the slope of the given line. That's the first thing we want to do. Write an equation of a line that contains this point, 6, 2, and is perpendicular to y is equal to -2x plus 7. Well, this step is very easy because we are given the equation of a line in slope-intercept form. Now, if you forget what slope-intercept form is, shame on you because I just talked about it on the previous page. Now, slope-intercept form is y is equal to mx plus b. If you're a student in my class, remember the word wall. They're up on the word wall. So to find the slope should be a very simple thing for you to do. The slope of this line is -2. To find it, I mean write it down. So the slope of this line is -2. Since we want to find the line perpendicular, we want to find this slope's negative reciprocal. I'm going to abbreviate here. Find the negative reciprocal. We want to find the negative reciprocal of the slope from here. So the negative reciprocal of -2 So the new slope we're going to find is going to be the negative reciprocal of this because we want the line perpendicular. So the negative reciprocal of -2 over 1 is a positive 1 over 2, a positive 1/2. The reciprocal of 2 over 1 is 1 over 2, or 1/2. And the negative of a negative is a positive, that double negative thing we've talked about in class. So the new slope that we're interested in, of the line we have to find, is 1/2. So we're going to use point slope. Sorry about that. Let me pull that back up. We're going to use point slope what I mean by use it is write it down. Y minus y sub 1 is equal to m times the quantity x minus x sub 1. Key thing is here, where are the numbers coming from? When I say use it, I mean write it down and put the numbers in. We're going all the way back to the top of the problem where it says write an equation of a line that contains 6, 2. Well, this is our x1 and our y1, as it has been for the past 4 lessons. So we're going to write this down and we're going to substitute the numbers in. Y minus, y1 in this case is 2, so y minus 2 equal to the slope 1/2 times the quantity x minus x sub 1. X sub 1's all the way up here, which is a positive 6. I want our final answer in slope-intercept form. So we're going to write that out as our final answer. Final answer in slope-intercept form. I abbreviated there, slope-intercept form. Now remember, what slope-intercept form is this? Y equals mx plus b. Now I've answered some very good questions in class. I put a parenthesis when I didn't need one. Let's be y is equal to mx plus b. I've gone over some problems with some individuals in class in prior lessons where we've done the same skill, taking something that's in point slope and putting it into slope-intercept form. And if you look at slope-intercept form, y is equal to mx plus b compared to what you have to get this y term by itself. So basically, we have to just subtract 2 from both sides. But before we do that, we have to get rid of these parentheses by distributing that 1/2. That's a pretty simple thing to do. You shouldn't freak out about it. All right, I can't move it the way I want to, so what I'm going to do is distribute that 1/2 at this point. When I distribute that 1/2, that's going to give me 1/2 x. 1/2 times x gives 1/2 x. Don't need to do anything with the fraction except put it in front of the x because it has a coefficient of 1. 1/2 times a minus 6. Well, a positive times a minus is a minus. and 1/2 times 6. 1 times 6 is 6, and 6 divided by 2 is 3. And I'm going to write down what's on the left-hand side, y minus 2. Now all I have to do is add 2 to both sides. Mistakenly put my minus 2 in there. The minus 2's go away, leaving us y on the left of the equal sign, and on the right of the equal sign, 1/2 x minus 1, because negative 3 plus 2 is negative 1. So there's the equation of a line that's perpendicular to this line here. This isn't an answer. I'm circling it or squaring it off so you can see that this line and this line will be perpendicular, and this line is going to go through this point right here. Now let's check that out with a graph. Now what I mean by check it out with a graph, I actually want to show you in this video, I don't think I've ever shown this in a video, exactly how you're going to need to enter these equations so you can use this online graphing tool. Now if you're my student, the link is on the other resources page. So you want to, it's the top link there, so you're going to want to check it out. But let's go back to the video here. Now the given equation is y is equal to negative 2x plus 7. Y is equal to negative 2x plus 7. Now I'm going to enter that in the red graph. So I'm going to enter 2 times, actually it's negative 2, so I need to put that in as a negative. Negative 2 times x plus 7. And you can graph that right now if you want. You can see there's that line right there. Now, the other equation then was down here, y is equal to 1/2 x minus 1. So it's 1/2 x minus 1. When you put this fraction in, you're going to want to put parentheses around it. 1 divided by 2, close the parentheses, and then times your variable x, and it was minus 1. Let's go look, I forget. Yep, minus 1. So we have the equation 1/2 times x minus 1 here. And when we graph that again, the new line comes up, and we can see the two lines do appear to be perpendicular, and the point needed to go through, or the second line we graphed, y is equal to 1/2 x minus 1, needs to go through the point 6, 2. So let's see if it does go through 6, 2, if our work was good. So checking out the graph from the origin, and it's the blue line we're working with, so let's use the blue line. From the origin, we need to go to the right 6. That doesn't show up so well, but to the right 6, and then up 2. Yeah, and it appears to be lined up real well there. So the work we did in that equation, and here again, a visual representation of what we did by hand. The equation that we were given was y is equal to negative 2x plus 7, and the equation that goes through the point 6, 2 that's perpendicular to it is y is equal to 1/2 x minus 1. And we can see we did that work by hand, and here it is represented in a graph. This has been Mr. Pilarski with linear equations and perpendicular lines. Thanks for watching. Bye-bye.